You know that little keypad by your door? Ever wondered what's really going on inside? It seems so simple, right? But behind that plastic is a constant battle of wits. Today, we're going to pull back the curtain and uncover the surprisingly clever tech that keeps your home safe and stays one step ahead of any intruder. It all really starts with this thing, this unassuming metal box, probably tucked away in a closet somewhere. It doesn't look like much, does it? But this is the command center. It's the brain of your entire security system. So what is it actually doing in there? Well, let's open it up and find out. All right, first up, let's meet the team. These are the core components, the players, that all have to work together to protect your space. So inside that protective metal box, we just call it the can. You'll find the panel. And make no mistake, this is the real brain of the operation. It's the motherboard making all the decisions. Now you talk to it using the keypad. That's your interface. It gets all its power from a dedicated plug called the transformer. And if the power goes out, no problem. A backup battery kicks in instantly, so this system never ever sleeps on the job. These are the key players. But here's where it gets really interesting. An alarm system doesn't just see a building. It sees a space that it needs to organize and protect with, like, military precision. And this is where the real strategy comes in. So to understand that strategy, you have to know about two things: zones and partitions. A zone is super simple. It's just one sensor. Like the little magnetic contact on your front door, that's one zone. A partition, though, that's a group of these zones. Think of it like creating invisible security bubbles inside your property. It lets you arm one area while, leaving another one totally free to move around in.
And here's a perfect real-world example. Imagine a building that's part office, part warehouse. The office folks, they might show up at 8 a.m. and need to disarm their area. But the warehouse, that needs to stay armed and locked down until a manager gets there at 9. Easy. You just put all the office sensors in partition 1 and the warehouse sensors in partition 2. Now they act like two completely separate alarm systems, even though they share the same brain. It's brilliant.
Okay, so we've organized our space. Now, let's get down to the actual wiring. And I gotta say, this is my favorite part, because it's this fascinating cat and mouse game between the people who design these systems and a clever would-be burglar. So most sensors use this super clever trick called a normally closed circuit. When your door is shut, a continuous, low-voltage electrical signal is just humming along through the sensor. It's telling the panel, hey, all good over here. But if a burglar just snips the wire, that signal is broken instantly. The panel sees that break and immediately, boom, triggers the alarm. It's a simple but really effective first line of defense. So the system is designed to fail securely. But, a clever intruder knows this stuff. What if they try a different trick? Instead of cutting the wire, they could strip the insulation off and just twist the two wires together. This creates what's called a short circuit. Now, to a basic alarm panel, the electricity's still flowing, right? So it gets fooled. It thinks the door is still secure, even when the burglar swings it wide open. So how do you outsmart that move? Well, here's where it gets really, really clever. We add this tiny, brilliant little component, an end-of-line or EOL resistor. This little guy gets placed right inside the sensor at the very end of the wire, and it lets the panel do something much smarter than just checking if the power's on or off. It can now measure the exact amount of electrical resistance in the wire. It's kind of like checking a signature instead of just seeing if a letter showed up. And this is the checkmate move, because the panel now knows 3 distinct states, not just 2. If it reads a very specific resistance, let's say 2200 ohms, it knows the resistor is there and the door is secure, all good. If it reads infinite resistance, well, the wire's been cut, that's an alarm. And what if it reads 0 resistance? It knows the intruder tried that short circuit trick, that's a tamper alert. Game over. The circuit is now almost impossible to fool. Okay, so our wiring is incredibly smart, almost unbeatable, but the physical setup is only half the battle. Now we have to actually tell each of those smart sensors how to behave. We have to program them.
And we do this by giving each zone a zone type, which is pretty much its job description. A front door sensor gets set to entry/exit delay. That gives you a little grace period to come in and punch in your code. A window sensor, though, that's set to instant. No excuses. If it opens, the siren goes off, period. And motion sensors are often set as interior followers. They're smart enough to know that if the front door opened first, they should just wait for you. But if they detect motion without that door opening, they know something's wrong and trigger an instant alarm.
So when you put all of these pieces together, you've got the robust hardware, the logical partitions, the unbeatable wiring, and the very specific programming for each and every sensor, you get something way more powerful than just a noisemaker.
And this really brings us to the main takeaway. A good alarm system isn't just a collection of sensors. It's a multi-layered logical system, and it's designed from the ground up to anticipate and to defeat threats. It's a system of pure applied logic, always trying to stay one step ahead.
It makes you wonder, doesn't it? That simple keypad on the wall is really the gateway to this deeply logical and layered defense system. And it just begs the question, what other everyday technology is hiding a similar level of thought and ingenuity, just waiting for us to look a little closer? Thanks for joining me for this one.